on number 22, this actually is from section 3.5 on symbolic argument. So we're asked to use a truth table to determine whether the argument is valid or invalid. And as we're reading, let's try to come up with three statements. I've written them out here that can be translated into a symbolic form. We have, if you're infected with the measles, then it can be transmitted. The results are grave, and it cannot be transmitted. Therefore, if the results are not grave, then you are infected with the measles. So the three statements that are used in that argument are P. We're going to let P represent you're infected with the measles. Q will be representing it can be transmitted. And R will represent the results are grave. So now let's translate these sentences into symbolic form. The first sentence, if you're infected with the measles, then it can be transmitted, would be an if P then Q. The results are grave and it cannot be transmitted would be R and negation of Q. Therefore, if the results are not grave, then you are infected with the measles. So therefore, negation R, or if negation R, then P. Now the way that we then translate the symbolic argument or write it into a truth table form, we take the first premise and the second premise, so premise 1 and premise 2 will be the antecedent of your conditional statement, and then the consequent, so it should always follow that negation R then P. So it's going to look like this on your truth table. We have premise 1, we have premise 2, okay, and then connecting those, it is a conjunction. So for premise 1 and premise 2, that becomes the antecedent of the conditional statement. And we're saying if premise 1 and premise 2 happen, then the conclusion necessarily will occur. So if this is a true symbolic argument, if it's a valid argument, then when I fill in this truth table, underneath the conditional sign, I should have all trues. And that would mean that in every case that the conclusion would necessarily follow that set of premises. The next step in setting up my truth table is going to be, because I have 3 statements, then I have 8 cases. And as you organize your truth table, it's standard under the first statement, which is our P statement. We're going to, so we can organize this well, we'll list 4 trues, 4 false. And then for my Q statement, I'll alternate 2 trues, 2 falses, 2 trues, 2 falses. And then for my R statement, I'm going to alternate every other one, true, false, true, false, true, false, true, false. And that, if you look, I don't have any cases that are the same. That's going to give me every one of the 8 possible cases with different truth values, either true or false. Now I'm going to start to fill in my truth table. Underneath, if P then Q, if you just look at those 2 columns, remember that in a conditional statement, the truth value is only false if I have an if true then false, which would be for these 2 cases. So I have false for those 2 cases, everything else is true. For my for the next part of the truth table, I filled in the truth values for R. So I copied down the R column. I negated Q. And then the conjunction of those 2, I looked for any statements or any cases where I had a true and a true. And if it's true and true, then the truth value is true. Everything else is false. So the conjunction between those two statements, when I compare those columns that are highlighted, the conjunction, I'm looking again for any statements where any cases where both statements are true. So in the seventh case, they're both true, so I have a true, true is my truth value. And then for the rest of that column, I'm going to fill in with false. And then for the consequent, first I filled in negation R, copied down the P column, and then the conditional statement is only going to be false in a case where I have if true then false. So that sixth and eighth case there would give me false results. And then when I go to compare for the conditional, the answer column from the antecedent and the consequence, then the only way that I can come up again for a conditional statement with a false conclusion would be if I have an if true then false. Well, here I have all false except for one true, and this is an if true then true, so that one turns out to be true. So my answer column, I have all trues, which means that it is a valid argument.